Hello students, in the previous lecture we see the chain rule in double function term. In this lecture we have to see how to take the derivative or how to apply the chain rule in triple function. Find dy by dx. First problem, y is equal to log of tan of 4 minus 3x. In this problem, when we going towards x, the outer function is log, middle function is tan, and inner function is 4 minus 3x, or inner term is 4 minus 3x. Log is the outer, tan is the middle, 4 minus 3x is the inner function. Only consider outer function, that is log fx. Derivative of log x 1 upon x, derivative of log fx 1 upon that fx. Into derivative of this fx, write it numerator. Derivative of log some term 1 upon that term. Into derivative of this term, write in numerator. Derivative of log fx 1 upon that fx, 1 upon tan 4 minus 3x, into derivative of tan 4 minus 3x, write in numerator. Now in this function, tan is the outer function, 4 minus 3x is the inner function. Therefore consider tan as a outer function. Now derivative of tan fx is sec square fx into derivative of fx in numerator. Derivative of tan theta is sec square theta into derivative of theta in numerator. Now sec square 4 minus 3x into 1, sec square 4 minus 3x, derivative of 4 is equal to 0, derivative of minus 3x is minus 3. 0 minus 3 is minus 3. Answer will be minus 3 sec square 4 minus 3x upon tan 4 minus 3x. In second problem, y is equal to sine of e raised to 3x is the given function. In this function, if we differentiate with respect to x, dy by dx, outer function is sine. If we going towards x, outer function is sine and middle function is e, and inner function or inner term is 3x. Therefore first we have to take derivative of sine of some term. Derivative of sine fx is cos fx into derivative of fx in numerator. We know that derivative of sine x cos x. Derivative of sine fx cos fx into derivative of fx in numerator. Derivative of sine f of x is cos f of x into derivative of this f of x, right, in numerator, or derivative of sine some term cos of that term into derivative of this term, right, in numerator. Now e raised to 3x, we have to take the derivative of e raised to 3x, in which e is the outer function, 3x is the inner function. E is the outer function, therefore we have to take the derivative of e, that is e raised to fx. Derivative of e raised to fx is e raised to fx into derivative of fx, right, in numerator. Derivative of e raised to 3x is e raised to 3x into derivative of 3x in numerator. Now these two terms remains as it is. Derivative of 3x is equal to 3. Derivative of kx is equal to k. Now take 3 e raised to 3x in front of cos. Therefore 3 e raised to 3x cos of e raised to 3x is the answer. Next, y is equal to root of tan of root x. Y is equal to root of tan of root x. In this problem, differentiate with respect to x, derivative of y dy by dx. In this function, root is the outer function, tan is the middle function, and another inside root is the inner function. When we going towards x, root is the outer, tan is the middle, and again root is inner function. Therefore root is the outer function. First consider only outer function. Derivative of root x 1 upon 2 root x, derivative of root fx 1 upon 2 root fx into derivative of fx, right, in numerator. Derivative of root fx 1 upon 2 root fx into derivative of fx, right, in numerator. Derivative of root tan of root x 1 upon 2 root tan of root x into derivative of fx, that is tan of root x, right, in numerator. Derivative of root some term 1 upon 2 root that term into derivative of this term inside the root, right, in numerator, d by dx of tan of root x. Now tan is the outer function and root is the inner function. Therefore taking the derivative of tan fx, derivative of tan fx, derivative of tan some term is a sec square of that term into derivative of this term, right, in numerator. Derivative of tan of root x is a sec square of root x into derivative of root x, write in numerator. We know that derivative of root x 1 upon 2 root x, derivative of root x 1 upon 2 root x, sec square of root x into 1, sec square of root x, and 1 into 1 1, taking 2 root x in front of 2 root tan of root x. 2 2s are 4. Now remaining term is root x and root tan of root x, but we taking common this root and write the multiplication of x into tan of root x. Therefore answer is sec square of root x upon 4 into root of x tan of root x. Before taking next problem, first we some important points in the problem. D by dx of x by 2. There is a term d by dx of x by 2, in which 1 by 2 is the constant term taking outside the derivative, that is 1 by 2 d by dx of x. Therefore 1 by 2 derivative of x is equal to 1. 1 by 2 into 1, 1 by 2. But in the problem we write directly d by dx of x by 2 as 1 by 2. If there is x by 3, we write derivative of x by 3 is 1 by 3. Next, there is a formula sine angle to sine half angle cos of half angle. Sine angle to sine half cos half. Sine angle to sine half cos half. Sine any angle, that is x, to sine half angle, that is x by 2, cos of half angle, that is x by 2. Also 1 upon a sin x is equal to cosec x. 1 upon a sin x is equal to cosec x. Now next problem is y is equal to log of tan of x by 2. Differentiate with respect to x, dy by dx, derivative of log fx, derivative of log x 1 upon x. When we going towards x, outer function is log, middle term is tan, and inner term is x by 2. Outer log, middle tan, and inner term is x by 2. Derivative of log fx 1 upon that fx, because derivative of log x 1 upon x. Derivative of log some term 1 upon that term into derivative of this term, write in numerator. We know that derivative of tan fx is sec square fx, derivative of tan x by 2 is sec square x by 2 into derivative of x by 2, write in numerator. Now sec square x by 2 into 1 sec square x by 2 upon tan x by 2. We know that derivative of x by 2 is 1 by 2, because derivative of x is 1. Now in such a condition, sec square and tan, first we have to make them in a basic ratio. There are two basic ratio, sine and cos. Every trigonometric ratio is made from these ratios, that is sine and cos. Now sec square x by 2, write it as 1 upon cos square x by 2, 1 upon cos square x by 2, and tan x by 2 as sin x by 2 upon cos x by 2. 1 by 2 remains as it is. Now cos x by 2, cos x by 2 get cancelled. Write 1 by 2 in front of this term, 1 by 2, 1 by 2 into 1 upon cos x by 2 into sin x by 2. Now this is the main denominator. Write cos x by 2 into sin x by 2. Therefore 2 sin x by 2 into cos x by 2. We know that sine angle 2 sin half angle cos of half angle. Sin x 2 sin x by 2 cos of x by 2. Therefore 2 sin x by 2 cos of x by 2 is sin x. If half angle is x by 2, then full angle is x. Therefore 2 sin half angle cos half angle is sin of full angle, that is sin of x. And 1 upon a sin x is equal to cosec x. 1 upon sin x is equal to cosec x. This is the important question in this type. Thank you.